Hi viewers. In this video, we are going to discuss about some simple hydraulic circuits. In this module, we are discussed about direction control valves, flow control valves, and what are the other regulatory valves. Okay, then what is the how we have to draw these symbols like that we have studied. So, what is the function of hydraulic system? As the main hydraulic system is consist of some components which are going to help for getting some final output. Either may be a rotary system or it may be a linear system. In any industries, we are going to use some hydraulics or pneumatic systems, so that we will get an output. So here in the hydraulic system, we are going to use the hydraulic energy, and we are converting the hydraulic energy into mechanical energy. And for that we need some set of equipments. Either it may be a filter, it may be a regulating unit, or it may be a direction control unit or pressure relief unit, whatever it is. So many components are going to be involved in a system, so that we can get the output from the hydraulic energy to the mechanical energy. But if I want to explain this my system, it is better to explain in a diagram. But since there are so many different types of valves and different type of components are there, with the help of symbols, if you explain, then it will be easier to understand the concept. So a circuit diagram is needed for making to understand how the hydraulic system is going to be function. So here the circuit diagram, how we are going to do it, and one or two simple circuit diagram we will see, and we can understand the concept how it is going to be function. So this is one of the simple circuit. Over here we can see one from this figure we come to know the symbols. Through the symbols we can identify this reservoir. Okay, this symbol shows the tank or the reservoir. Whatever the symbol shows, it's a tank or the reservoir, right? Next one is this is the pump, which is gear pump symbol, which is going for the pump we are going to use here. Simple is shown as a simple mechanism, because for rotation symbol we want to do it like this. And here this is the pressure relief valve, and this is the solenoid operated or manual operated directional control valve. So four ways over there, part 1, 2, 3 and 4. So these four ports are there, and it is connected. It is going to be connected with three position. This is a 3 to 4 way valve, and this is the reciprocating cylinder, which is help to move the load up and down. So this is how now let me see how it is going to be function in by showing in different position. So now I am going to tell the position to this in this position. So what will happen if I keep the directional control valve in this position? So liquid which comes through this pipe when pump is working, it comes and it crosses, since it is open. So it goes here and it will move move the piston upward, and already the liquid whatever it is, it comes and come this area, and it goes to the liquid tanker or reservoir. Okay, this is how a piston can be moved in one direction, and let me see in the other direction of this also. So when it goes to the end, at most end of this, when the piston moves upward, then what will happen is here this end of pressure is getting created more. Okay, then the pressure is getting created more automatically. This is where the liquid goes to remaining things is going to be get pressurized. So pressure relief valve will be helpful for reducing the pressure over there. And in this direction, next if you change the direction of flow, then the liquid flows in the opposite direction. So the liquid comes and it goes to the top side of the cylinder, and it pushes the piston out downwards, and the liquid already which is present here this side, it will move to the tank automatically. So this is the way how this valve is getting connected. By moving the directional control valve up down, we can make it. And this is another method of hydraulic system, another hydraulic circuit. So here we can see a symbols of this is a tank. Okay, and it is connected with the port, a tank is there, and this is the pump over here, and this is a relief valve and direction control valve, just like that same. Four here, six, you can see the four way but three positions. So position 1, position 2, position 3, these three positions we can make it. Now it is getting closed. The liquid now if moves, it cannot enter into the port, since the port P is getting locked, so it cannot either A or B, it cannot join. So that the pressure which is created in the pump, it goes through the relief valve, and this pump now the liquid moves to the reservoir, because since there is no way to go upward, so the liquid is bypassed and it goes to the tank. This is how the initial position is taken. And if you take that's what, if it gets stops, then it won't go further. So next slide will let me go for this movement of slides. So when I move this piston one side, the direction control valve moves to the one direction. So what will happen, you can see here, this direction, it is moved, the liquid which is moved can be moved through this direction control valve, and it moves to the left end of the piston at the top. So high pressure is getting created at this area, because it is going to be push the piston still. So now it is going to be move the piston towards the right side. So the right side liquid automatically it comes to the tank. Okay, so this will happen when the direction control valve is connected, the port P is connected with port A. So this is what it happens, the port P can be connected with a port A when this position, first position, if it keeps like this. So in the next slide we will see further how it is getting moved. So now it is moved to the half of the right direction, and further the cylinder it's moved to full extent. Then we are going to, that is from the left side, from left to right, I am going to activate. So that time now you can see the position how it is activated is P to B. So this port is now it is connected to P to B, so this will be connected. So this, when we are activating this solenoid position, then the liquid is moves at the back, so it is going to be push the rod in the front side. So now this will happen when it pushes to the front side. So then the liquid which is in the front, okay, so this is going to be, the rod is going to be moved in this direction for the in the next motion. So when we are going to move this to the next slide, so that what it indicates that it moves and it will make pressurized in this. And the third one is meter in and meter out circuit. So meter in circuit is in this type of circuit, the flow control can be taken place when the movement is taken in the input. When a control valve is, flow control valve is placed to control the fluid which is going to the actuator. So from the pump towards the actuator, when it is moving, when the liquid is moving, so I can control the movement, retract, what is that, extension stroke, let me take as an extension stroke. When an extension stroke has to go very slow movement, okay, when it is has to follow a slow movement, that time I am going to fix a flow control valve over there, that control valve which will guide to move the piston very slowly. So allowment, the amount of flow, amount of fluid which is going through this flow control valve will be controlled with the help of this flow control valve. So this is meter in circuit. In circuit, flow control valve will be present in between the pump and the actuator. Okay, so that is in, when the liquid is going into the actuator, you are going to keep it for the one for movement. In, suppose if I want to control the retraction stroke very slowly, so that time what we can do is the reverse side, we can keep the flow control valve in the direction where actuator to pump, when the fluid is going to move from the actuator to the pump, return. So when it is getting returning, that time if you keep the flow control valve and if you control the flow, automatically the return movement will be very slow, so that we can control the movement of the actuators, slow movement and the fast movement of the actuator, by keeping flow control valves in which direction, either while going in or coming out. So that is called meter in circuit and meter out circuit. So these are all the hydraulic circuits which are helpful to understand the concepts of hydraulic systems. Okay, thank you very much for watching the video. The advantages, normally it will be the, for all industrial advantages it will be